In this video, we are going to discuss problems based on Kepler's third law. Galileo measured the orbital radii of Jupiter's moon using the diameter of Jupiter as a unit of measure. He found that Io, the closest moon to Jupiter, has a period of 1.8 days and is 4.2 units from the center of the Jupiter. Callisto, the fourth moon from Jupiter, has a period of 16.7 days. Using the same unit that Galileo used, predict Callisto's distance from Jupiter. So let's write down what the question has given us. Since we have two satellites here, I will consider Callisto to be my satellite A and Io to be my satellite B. You can choose any one of them as A and B. I choose the satellite which has a missing term as A to make my rearrangements easier. So let's write down the given quantities. Time period of Callisto, which is TA, is 16.7 days. Its distance from Jupiter is what we need to find. Time period of Io, I will write as TB, which is 1.8 days. And its distance from Jupiter, RB, will be 4.2 units. Kepler's third law says that ratio of time period TA over TB squared will be equal to ratio of average distances Q. I want to find what is RA. If I want to find RA, I need to get rid of the term RB cube. And since RB cube is in the denominator here, when I move it to the other side, I need to multiply with it. So we multiply RB cube on both the sides and we get RA cube equals TA over TB squared times RB cube. I want to calculate RA, not RA cube. So to find RA, we need to take cube root on both sides. Hence, I will get RA to be equal to cube root of the whole term, TA over TB squared into RB cube. And then we solve taking cube root. TA is 16.7, TB is 1.8 squared times RB, which is 4.2 cube. And when you solve this, you get your RA as 18.5 units, which you can round off to 19 units. Let's solve another similar question. You have two satellites in orbit around a planet. One satellite has an orbital radius of 8 times 10 to the power 6 meter. The period of rotation for this satellite is 1 times 10 to the power 6 second. The other satellite has an orbital radius of 2 times 10 to the power 7 meter. What is the satellite's period of rotation? So since the second satellite has a missing quantity, I'm going to denote that satellite as A. And the first one we will call as. So let's write down what the question has given us. I have the distance of B, which is 8.0 times 10 to the power 6 meter. We have its time period, 1.0 times 10 to the power 6 seconds. Distance of the second satellite, RA, is 2 times 10 to the power 7 meter. I need to find its time period. Again, we use Kepler's third law. Kepler's third law says that ratio of time period squared equals ratio of average distances cubed. Since I want to find TA, we will multiply with TB squared on both sides. When you are rearranging the term, please do not forget the square and the cube. Include them while you're rearranging them. So I will write TA squared equals RA over RB cube into TB squared. I want to find TA, not TA squared. So to find TA, we need to take square root on both sides. We write TA equals square root RA over RB cube into TB squared. When we substitute, RA is 2 times 10 to the power 7. RB is 8 times 10 to the power 6 cube times 1 into 10 to the power 6 squared. And you get your TA as 3952.847 seconds, which you can write as 3.9 times 10 to the power 6 seconds. Be careful when you're taking the square root and cube root for calculating your values. If you want to find the time period t, we take square root of the quantities. And if you want to find the average distance r, then we take cube root. If you don't put these two values correct, your answer may come out to be wrong. So be very careful in when to take your square root and when to take the cube root.